Hello there, and welcome to CS202 Online. Hope you're having a wonderful Wednesday. Today we're going to be talking about more pointers and more memory allocation stuff and some peculiarities that involve pointers. Thank you. So let's go ahead and get going. So last time I like saying we, but I mean I showed you how to do two-dimensional array dynamically allocated. I thought we kind of warm up by doing a three-dimensional allocated array. From there, I will be talking about using pointers in both functions and classes because that's useful to know. And then I will do the C stuff since I told you that I wanted to show you how to allocate memory in C if we have a little bit of time. If not, I'll show it to you next time. So yeah, since I'm showing you that, might as well pull this one out. So yep. Okay, so let us go ahead and begin. All right, here we go. So this is the two-dimensional array code. I will be posting this code online as a reminder since I haven't told you in a while. There is on Canvas a download link in one of the articles, the one that has all the video lectures in YouTube. Not all of them, but like the shortcut to the playlist. There's a download link for all the code that I do, and I update it every Wednesday's class. So it's the same link, the same file name. I just update the contents. It just makes it easy for me. So FYI, all that code is available there so that you can download and practice and play with it. So yeah, okay. So let's look at this code. This code makes a two-dimensional array and then goes ahead and deallocates it. So as I was talking last time, the big trick when it comes to multi-dimensional arrays in C++ is the concept of, of the fact that we can only have one-dimensional arrays in memory. And then anything else is sort of virtually done in the sense that it's not really a 2D table. It's a bunch of 1D tables on top of each other, like stacked, right? So in main memory, everything is just like one big one-dimensional column. In fact, even an array is stacked, right? Because like each line of memory, each address can hold, let's say, 4 bytes. And even if you have something like a double that requires 8 bytes, it technically takes 2 slots of memory, right? An array that's like of 5 integers is going to take 1, 2, 3, 4, 5 slots in memory, right? If it was doubles, it would take 10, right? Because each would take 2. Well, we are expanding that concept with two-dimensional arrays. You store one of the rows first, and then the second row, and so on. And so for a two-dimensional array is done that way. And how we are doing it is, instead of just putting it all in one big block of memory contiguous, what we're doing is the first array is just an array of pointers, right? And that array of pointers is going to point to different little one-dimensional arrays that represent rows. Now, those don't have to be stored in order. In fact, they're probably not stored in order, if I was to guess. Because at the end of the day, it's just a pointer, right? And the pointer could be holding an address anywhere in memory. And who decides what address you get? The operating system does. And so you have no control over that, technically speaking. And so anyways, that is how you're making a 2D array. You're making a 1D array of pointers, and each of those points to each of the rows, okay? If it helps to visualize it, you could turn 90 degrees the array of pointers so that you could think of it like each one pointing to a different level per se. So anyways, let's go ahead and expand this concept into a three-dimensional array. Okay? So I think maybe I'll switch to the iPad first because otherwise it's going to be really tiny. So what would the 3D array, and I actually have conveniently here, I just noticed that actually, but I'm kind of glad I had it open, this figure, right? This is what a 3D array would look like if you were trying to visualize it, right? A 2D array is just the rows and columns, but now with the third dimension, that is going to be depth, right? So it's like a cube. So in this case, we have a 3D array where the dimensions are a 3 by 4 by 2. 3 is the height per se, 4 is the width, and 2 is the depth per se, okay? Or length, width, and depth, whatever you want to call them, doesn't matter. And so the way we visualize it is we sort of stack two of them. We stack two potentially two-dimensional arrays together, right? Because like we color code this. This is just a this is a two-dimensional array right here, right? That's it. That's all this is. And then behind it is another two-dimensional array. And by stacking them together, we have now made a three-dimensional array. So even as I would say like humans, we don't really visualize the third dimension you know, in a different than just basically stacking a bunch of two dimensions together, right? So you can kind of think of that. Now, what would a four-dimensional array look like? Well, that would be tricky to draw, but you could potentially put these little cubes into like a bookshelf. You would just slide them in, each of them, right? So anyways, the way we're going to represent this in code is we are going to make an array, and we're going to do the same dimensions here, might as well, 3 by 4 by 2. So first, we're going to start out with the depth. How many layers, quote unquote, are there here? We're going to call these layers, okay? Just as a name. There's 2 of them, right? And so we're going to make 2 pointers. And each of those is going to point, and this time I'll do it vertically, I guess, since I was just talking about doing it vertically for visualization purposes, to another array of pointers that each is going to hold 4 pointers. And those pointers are going to hold the individual rows, which are going to be, oh, sorry, there's 3 of them. Apologies. I guess I was doing it, well, technically you do it this way too, but I want to do 3 by 4 just because it's less drawing. So where there's 3 pointers, because there's 3 of these here, so let me color code. 3 and 3. And then I suppose 2 here for 2 here. And then finally, green, let's do green. This one's going to represent these. Okay, so there's going to be 4 of them. The only arrays here that are actually containing integers, let's say there's integers here, since I said integer there, right here. The only actual data arrays are these ones, the green ones. Everything else is pointers. So when you're doing a multi-dimensional array, only the last dimension per se is actually containing data. Everything else is just pointers. And you will see that because you might think, well, are we not having enough space? Like, are we actually storing all the space here? Like, how much data can you store here in this 3D array? Well, you would store 3 times 4 times 2, which is 3 times 4 is 12, and times 2 is 24, right? So potentially, you're storing 24 items here, 24 integers. It turns out that if I draw this correctly, then each of these will indeed contain 24. Because this thing here that I already have, I'm going to duplicate it. Let me put it down here first so I can erase the other stuff that came with it. So like this stuff. There we go. So I'm duplicating the top thing, and I'm putting it here, and then just linking this one to that. And remember, with the pointer's only pointing to the first entry of that. So technically speaking, even these tiny arrows, they're not just kind of pointing anywhere. They're pointing to the first integer here, okay? So I didn't kind of draw that for all of them, but that's kind of how they're pointing, okay? So maybe I'll do one more like that, just so you get the idea. So like this one here is actually pointing to this spot right here, okay? And that one right there. And this one's pointing here, and then this one is technically pointing to the first pointer of that, okay? So that is how that is made. Now, here it looks nice because these are all neatly stacked on top of each other like that. But again, this could be somewhere in memory. So like if this is main memory, you know, these could be like here, and then these could be like down here, and these could be down here. They could be anywhere because you're asking for memory at different times when you're allocating this, and you're getting different places potentially. You may get them you stack, but you may not. Okay? So more than likely, because of how virtual memory works, it will show it to you like it's stacked. But in practice, physical memory, in actual practice, they probably will be just about anywhere in your RAM. So anyways, that's a 3D array right there. So now let us go ahead and code that. So let me go ahead and copy and paste this so that I can make it tiny, and I'll put it on the side of the screen so I can kind of show you how the code becomes, or how the drawing becomes code. So I think maybe that size will be good. Oh, it just like was like, nah. Oh, well, that happened. Let me get rid of this stuff. Let's try that again. I think that'll be good. Let's try it. I could make it a little bit bigger. How about this? I'll flip it vertically so it's even bigger. Because I can actually zoom in. Once I zoom in, it's too much. Okay, let's shrink it a little bit for a second here. And then, yeah, okay. Cool. So, that's what we want to code. And so, we could start with this, but, well, yeah, we'll start from scratch. I mean, I could copy and paste, but I feel like you will not, you might get lost if I copy and paste. So we'll start from scratch, okay? So, all right, this is going to be a 3D array that we're making. And so, remember, when you're building these multi-dimensional arrays, you start from the outside in. So you start from like the yellow ones, or I guess that's more like a yellow-orange. And then you work your way to the reds, and finally you get to the greens, okay? But first you do the yellow ones, okay? Now here's the catch here. I did forget one more pointer technically. Oh, it's an ambulance. I did forget one more pointer, and that's kind of where everything is being held at the start. So that's going to be like our starting point. And that technically is going to point to the first one of these two. I don't know which one's the first one. I think this one's the first one since I flipped it, right? Doesn't really matter. But yeah. So technically I do need one more pointer because that's the one that is going to basically keep track of everything. Now, I could potentially get away without doing this, but let's just do it that way because it's cleaner and it follows a pattern that we've been doing so far. Plus, that means that everything is truly dynamic with the exception of that one red one there. Everything will be dynamic. So all will be done with new. And then de-allocate it with delete. Okay? So we'll call it, well, we can't start our variables with a number, so I guess we'll just call it R again. Why not? I was going to call it R3D. How about that? That's cool. Okay? Actually, this will be a good time to show you how to use functions with pointers, because let's go ahead and say that we want to make a function that allocates this pointer. Okay? So yeah. We'll kind of throw a curveball here so that we can also see, you know, hit two birds with one stone kind of thing. No damage intended to the birds, but yes. Okay, so we're going to create a function called make3darray. Okay, and what we want to do is we want to make our pointer here that is going to be not a single pointer, but not a double pointer either, but a triple pointer, right? Because count, if you start from the red and you get all the way to the green, count how many asterisks you have to go by. You have to go by the red one, you have to go by the yellow one, and you have to go by the other. Oh crap, I have two colors of red. I don't like that. Let me change that to a different color. There, purple now. Animal reviews. Yeah. At first I talk about hitting two birds with one stone. Then I talk about in my assignment about dog at the end. So yeah, it's very, very violent class. So yes. Okay. So we got ourselves a pointer in purple. That's the starting point. And then as we get to the green, we would have to go through the yellowish. We'll call that yellow, but that's really just like a really weird yellow tone. Okay, we go to the yellow, then the red, and finally we get to the green, right? So we have to go through 3 pointers. So because of that, we have to actually declare a 3D array with the triple asterisk. Okay, so array 3D. There we go. Cool. Now we gotta allocate it, but we are not gonna do that ourselves directly. We're gonna make it through a function so that I can show you how to make it through a function. So what we're gonna do is we're gonna make the function return the array itself. Now you're like, whoa, wait a second. A function can return an array? In 135 they said that was not true. Yes, they were not wrong. You can only return one single item in C++. However, you can get around that by returning a pointer, which is still a single item. It's, you know, this little purple cube is just one cube, but it could be pointing to an entire army of squares. Technically, here are all the green ones, right? So, yes, you can return just one thing in C++, but that one thing could be a pointer to a lot of things. So that's what we're going to do. And so we're going to say our 3D is going to get the result of 3D array. And in our 3D array, we're going to take 3 parameters, which are going to be the dimensions we want to make our array, because that's pretty cool. So we'll make them. We'll make the same one we did there, which is a 2 by 3 by 4. I think that was what we did. Yeah, 2 by 3 by 4. Okay. And so that's the whole function. Now we got to code the function. Okay. So in here, we're going to call the 3 dimensions I, J, and K, because it just seems like that will be good, because that will be basically our for loops. And this is not void, but what this function is returning is a pointer. So what kind of pointer? It's an integer pointer, but it's not just a single pointer. It's not just a double pointer. It's technically a triple pointer, or a pointer to a pointer to a pointer, right? And so that is actually the return type that we're going to use, okay? So like, for example, because I know you were here before, you took me for 202 in the summer. This is something that we don't really cover, so you get to see it now. But in the normal semester. But yes, you can have pointers that return, functions that return pointers. And I do have an example of this in Canvas as well. So yeah. All right. So anyways, this function here, we are going to go ahead and start out by making a temporary pointer, which we'll call R. And it's still a triple pointer. And we're going to allocate the first thing that this pointer is pointing to. So what is purple pointing to? It's pointing to yellow. So we're allocating an array of pointers, double pointers per se, because again, the yellow one has to go to the red one before it gets to the green. So that's 2 asterisks. And how big is that? That is going to be the size of I, which is the first dimension that we see here, 2. Okay? So again, this line of code is creating a single pointer, and that pointer is already being initialized to point to an array. But it's not an array of integers, it's an array of pointers. And they're not any kind of pointers. They're pointer to pointers or double pointers, which is why I have 2 asterisks here. Okay? So, next line of code is, now we have this array with 2 pointers in it. Let's initialize those 2 pointers. So let's initialize the 2 yellow ones so that they point to their other 3D, or sorry, their other 1D arrays of pointers. So we want to make the red ones now. We have the yellow ones, and each of those yellows is pointing to a single 1D red array, right? So we want to make 2 of those. Now, because it's potentially based on the dimension, here we happen to have 2, right? That is what size I is. We want to make this flexible so that that number could be anything. Like I could change this from 2 to 3 or 5 if I wanted to, right? So instead of just hard coding 2 lines of code that says something like R0 equals blah, and then R1 equals blah, instead of hard coding it like this, we're going to do it with a for loop, right? But potentially that's all we're doing is we're initializing those 2 variables. So we'll make our for loop. Technically speaking, we want to do it I times, and we already have an I variable. So I didn't think this too far ahead how we're gonna, I want to do this, but that's not really gonna work. What I can do is I can you know, I'm gonna do this because whatever, why not? Technically speaking, I'm passing by value, right? So these are just copies, so I can play with them as much as I want. So what I'll do is I'll just use a while loop instead. And I'll say while I is greater than 0. And then each time it runs, it will decrease it by that. Okay? A minus minus. Not A minus plus, I minus minus. Okay? So really, this is just a weird way of doing it, but just to show you some different way of doing it. Essentially, all we're trying to do is get AR0 and AR1 to be assigned something. So we're going to do it this way. Actually, if we do it this way, we would actually go with 2, which is not a good spot. So we want to do the minusing part first. So it's going to go to 1, and then it's going to run again to 0, and then it's going to be okay. So yeah, okay, so like that. So put the I minus minus first. Otherwise, we would get arrays 2 and array 1, which we want array 1 and array 0. Otherwise, we're going out of bounds. Okay, so we're going to say R sub I which is going to, the first time this loop runs, is going to contain 1 because it starts at a 2, but then we make it 1, so now we got a 1. And then the second time it runs, which is going to get to 0, and then fill it with 0, and then it's not going to run a third time. So this is good. Okay, so we're going to assign this to be another array. We're making the red arrays this time. So the red arrays are still arrays of pointers, but now they're just a single pointer, not a double pointer. And how big are they? They are 3 at 3. And 3, 3 is the second parameter we have here. So we just put j in there like that. Okay? Good. Now that is done. So next we have to initialize each of the real green arrays, right? We have to do those now. We have to potentially initialize 6 of them. And those 6 are going to be in the form of something like array 0, 0, that's going to be the first one. Then the second one, then the third one, and then this is going to switch over to 1, 0, 1, 1, and 1, 2. So we want to initialize all of them. So we could do it in a completely separate loop, but we'd have to make 2 loops, right? But we could also just do it immediately after here by putting another loop inside, doing basically the same thing that we did it before. This time I'll do it with a for loop because why not? We'll do it the old school way of doing it, okay? So I can't use j, so I'll just use an x variable. And x is equal to 0, x is less than k, because that's the third dimension, k plus plus. Oh, no, j for this one, because we want to run for 3 times for each of the red pointers, not for the green ones. So yes. And then x plus plus like that, okay? So I could have done this same method for the outer one, but I decided to use a while loop because it's a free country. So yeah, okay. So we're gonna set ri and then rj, or in this case actually x, because that's the one that we're using here. And we're gonna assign this to be now the real arrays, which are the green ones. So those are regular arrays, no number of pointers, and they are of k size, like that. And that will take care of essentially allocating our 3-dimensional array. So let's kind of go over again. First, I make the yellow array here. And then I got to initialize those 2 pointers, which I do using the while loop. Right here, I am initializing each of them. So this line of code should run twice. One time with 0, one time with 1. It's making 2 arrays of size 3. Okay, and those are the red arrays. After I've made the arrays, I immediately go ahead and make the green arrays by running in a for loop that's running for each of the 3 pointers that I have here. So it's running for this pointer, and this pointer, and it's calling new on those with size 4, which is the k. Then it loops around, the whole while loop loops around, and then it makes this array. And after making this array, the for loop runs and makes the green array. So that for loop runs 3 times again. So that is how this works essentially, okay? Well, how it should work. You know, expectation versus reality is what we'll see in a second here. If I didn't screw up something. So it compiled. Oh wait, that's not the right one. That's dynamic3.cpp. It's still compiled. That's good. And if I run it, nothing happens because I'm not outputting anything. But let's run Valgrind because that'll confirm, because I should have memory leaks, right? Because I never deleted it. That should confirm if it's at least the right size. So in this case, it says 8 blocks and 144 bytes. Does that sound about right? I believe it does, because the indirectly lost are the red and green, and the directly lost are the orange or yellow. If you count the number of blocks I have, or the number of arrays, I have 1, 2, 3, 4, 5, 6 of the green and 2 red. 6 plus 2 is 8. Oh, sorry, you can't see it. Hold on. There we go. Okay. So here you can see it says 16 bytes in 1 block for the memory leak and 144 bytes in 8 blocks. You see that right there? Okay. So that's, if we then go back to the picture now. Yeah, I just saw. Thank you. There's a big delay. So as you see right here, there's 6 of the green and 2 of the red, so that's where the 8 is coming from. And then the one on the top for the directly lost, that's coming from the yellow one, okay? So 8 plus 1 is 9, which is actually the number of little arrays I have here, plus the individual pointer, which that one's just static. So yeah, so that's where that is coming from. So I can, with the memory leak, I can actually see that this is indeed working fine, okay? So yeah, let's go ahead now, and before we even initialize the array with numbers, let's go ahead and de-allocate the array, okay? So let's make another function, and in this case, we'll make the parameter of the function be the array that we want to de-allocate, okay? So now you'll get to see the other side of the coin. You saw, even though you haven't seen that this is fully working, but you can believe it is, that I can return the entire array here, okay? And I'll prove that to you in a minute once I do the initialization of the array. In fact, here, yeah, let's just go ahead and do that first, and then we'll do the delete, okay? So now let's make another function that initializes the array with some random data, okay? Alternatively, we could do that in the make3d array, but no, we'll do it separately, okay? So now we'll just say, we'll call a function called init array. This function's job is going to be to just fill the array with some stuff, okay? So the three things we gotta pass, or four things we gotta pass, is the array itself and the parameters, okay? So this is the really cool thing. When you gotta pass arrays in 135 the old school way, it's a headache. Like, you gotta do some weird parameters. Like, it's something like, it would be like R, and then you gotta put in like 2, 3, and then the last dimension you don't gotta put, and it's like nasty and disgusting. I don't like that at all. It's like horrible. Arrays by pointer like this are super smooth. You just pass the pointer, you don't have to worry about anything else. I mean, you gotta pass the dimensions too, but those are just numbers, right? So how do I do that? Well, I am gonna go ahead and just say R3D, and then my 3 dimensions, which are 2, 3, and 4. And that's it. So if I go in here and I make a function, and this one's going to be a void function, init array, and then I got the array3d, which is an integer pointer array, 3 pointers, technically speaking. And then we got the 3, the I, the J, and the K. But see that? See how smooth that is? Like, you don't have to worry about like the weird syntax. Like if this was a 3D array that was allocated by hand, like in the stack, you know, it was an array that you did something like A, you know, and did like 2, 3, and 4. If you did it this way, and you have to pass that to a function, like the parameter of the function would have to be like, I think something like this. Like that. That would have to be the parameter. And like, no, that's just weird. And not very portable code for something that changes the size. So yeah, this is so much nicer like this. The only hard part is, I guess, knowing the number of asterisks. But the number of asterisks is basically the number of dimensions. So yeah, that's a nice little hint, I suppose. Not hint, but handy dandy thing to remember. Tip. That's the word I'm looking for. It's a nice tip. Okay. So, anyways, this is just going to be basically 3 loops running. So you know, let's call them something else. Let's call them X, Y, and Z, because I just want to use a for loop here. Okay. So for int I is equal to 0, I is less than X, sorry, I plus plus. And then the second loop for int J is equal to 0, J is less than Y, J plus plus. And then the last loop for int K is equal to 0, K is less than Z, K plus plus. And then what we're gonna assign it with, so this will be I, J, K. Let's use rand. Mod 99. So that should make a number between 0 and 99. Technically, between 1 and 99. No, we'll do 0, because that way it's not. Yeah. Okay. So I do have to seed rand, so that will be easy to get random data. So let's just do srand. I think this. Wow. And then I think rand is in cstd_live, right? Or cstd.io or std.io. I don't remember. We'll see if it compiles. I forgot some semicolons. Or did I? Line 22. Yeah, I did forget a semicolon here. And then I forgot parentheses here. Okay. Segmentation fault. Yikes. R3D IJK XYZ 2 3 4 2 3 4. I'm not sure why. Let's see. GDB a.out. Oh, wait. Let me recompile with the G flag. Okay, run that. So it crashed in the assignment. Interesting. You can see that the dimensions were correct. I got 2, 3, and 4 being passed in. But this pointer is not right. Ooh, yeah, that does not look right. Oh, I see why. Ooh, big goof. We forgot to return. There's a valid returning function. We never returned the array. We just made it and never returned it. So that's why. We got to return array there. Otherwise, we make the array and it just lives in the void, basically. Okay? Because here's the thing. Dynamically allocated memory, we made the array. It exists in memory, but we never actually returned the pointer. And we were expecting to return a pointer so that we could use the array later on. So that's why we didn't notice that until now. So as you can see, the debugger is so nice because otherwise I would be still guessing right now. I'll hide so you can see what I was looking at. Basically, I ran it with GDB like that, and I could see that the parameters were correct, the 2, 3, and 4. I could see that those were valid, so that's okay. But as you can see, the address of array 3D was 0x3. That just sounds wrong. The odds of me having address 3 in memory is super low. So that was a sign that the pointer was messed up. And then of course I went ahead and saw that the pointer was messed up because I forgot the return state. So as you can see, debuggers cut debugging time by hours, literally. I would have probably been stuck here for 5 minutes trying to figure out. We forgot to save it. Let's save it and recompile. Okay, there we go. And run. And no seg fault. Perfect. See, it ran it terminated, exited normally, so that's good. We fixed it. Just so, let me put a breakpoint at line 21 and run it again. Just so I can show you. This time I stopped it at the same line the code would have crashed. Look at this address. This looks way more valid than address 3, right? So as you can see, that's how I knew that when it said address 3 there, that was a sign something was messed up with that pointer. So by the way, if you know how to set breakpoints in GDB, all you do is when you compile with the -G flag, that passes line numbers to the GDB. So then all you got to do to put a breakpoint to make the program stop is you put the B letter uppercase or lowercase b, like B as in Bravo, and then the line number, and then you hit R to run as in Romeo, and voila, it runs. So and then now the real question is, how do you continue? I think you just press run again. No, that's not it. C for continue, maybe? Yeah, C for continue. So there we go. Oh, it's still breaking up again in there because I have the breakpoint set, and when it came back there, it doesn't. So I'd have to spam this to go basically nonstop, whatever. But anyways, you get that idea. I have a video on debugger on Canvas if you're still lost with the GDB. So anyways, we have allocated the array. We still don't see anything happen to it. So let's actually print out the array. Let's make another function that prints out the array. How about that? So for the sake of so I don't run out of space in the code, I'm going to put the functions we already did beneath here. That way I don't run out of space, okay? As a good refresher, what do we do? Because right now, what happens if we compile? We're going to get an error if we compile like this. It's going to say that the functions don't exist, right? It's not declaring the scope. How do we solve that error? What we do, we put an extern, or better yet, we put a function prototype in the case that it's just in the same file. So the way we do that is we just basically put the first line of the code. In fact, I'm just going to copy and paste it. That one, and then that one. And technically speaking, while this will compile, we don't need the name of the function. I'm sorry, the name of the parameters here, just the type. So, but I'm gonna get rid of it because it looks prettier that way. Okay, and so now this code is okay again. Yep. And the cool thing about this is that now I can actually keep coding up here, you know, like here, and I won't run out of space because, you know, this goes out of the page. It's okay. All right. So the next thing we're going to do is we're going to make a function that prints the array. So we're going to call it print array. And I think at the end of this, what we're going to do is we're going to convert this into a class. I think that'll be the final step we'll do because object-oriented programming, right? So yeah, that's in our future, near future. So print array is basically the same thing. It's literally going to be like a slight modification of the init array class. In fact, I'm going to copy the body of the function first here, and then I'm just going to put I'm even going to copy the init array, like, yeah, the full function basically, because all I got to change is like the assignment to a cout essentially. So like this part from init array is just going to become print array. Everything else is the same except for here, instead of assigning something to the array, I'm going to cout the array. Yeah, like that. And then maybe I'll put a space in between here, and then in between the rows, I'm going to put an end line, but now I'm going to need curly brackets. And then between the dimensions, I'm just going to put like two line feeds. Like that. What are we learning? We are learning three-dimensional arrays allocated dynamically. Like such. Oh, I forgot the STD part. Oh no, I just forgot the semicolon. Okay, so now this will allow us to see what is inside of the dynamically allocated array. All right, so I forgot a semicolon still somewhere. Ah, here. Okay, we're good. Too much Python in my life. All right, so as you can see here, it's not very pretty because we have single digits. We could use yomanip to make it pretty, but whatever. But we can see, and by the way, every time it runs, it should give us a completely different array because of the brand. And we can see that it is indeed a 2D array. And if we compare this to what it should look like visually, which is the cube up here, this cube. So I can't, well, you saw the cube, right? So if you compare it to that cube up there that we had, that's essentially the same thing that we did. And if we break it down, in that cube, there's only 6 green rows, right? Each of those is actual data, which are matched here, basically. Each of these is one of the green arrays, 1D arrays, okay? So, you know, if we were to fill this in, it would be something like 80, 54, 27, and 48. Why do you have STD on lines 11, 12, and 14? Oh, because I forgot I had using namespace STD. So if you don't put, that's more of a question about what namespace means. So namespace allows you to not have to put where the cout function per se, or yeah, no, it's a function. That's not a function. It's an object actually. So yeah. The cout, this is an object, and so this is telling it where that object came from, which is from the STD quote unquote like group per se, or namespace is the right term. But yeah, so I could get rid of it and it would still work just fine because I have the namespace part. But if I got rid of this, then I would need it. So it's just some habit. So if you would like to remove it so you can kind of feel better, I can get rid of it. So, yeah. But anyways, so as you can see here, we have a 3D array. So the last thing I want to show you is how to deallocate it. Because if we run Valgrind right now, we should still see we have that memory leak. Let me hide the other thing. You can see we still got the memory leak in there. And by the way, that memory leak is going to depend on the size of the array. So if I made like, here, let me rerun it by making one of these dimensions bigger. So let's go ahead and make this a 12 for the first dimension like that. If we rerun it now on Valgrind, you can see that it got much bigger. Now we have 48 plus 1. So that would be 48 would be the number of green. Actually, we'd have, trying to think. Would we have 48 of the blocks, or how many would we have? Before we had 8, which was 2. So we would still have, because we changed the first dimension, we've essentially changed the orange one. So we have 48 arrays, but of those, 12 are orange. And then each of those 12s is going to generate 1 red. So that's basically 12 orange, and then 24. Not 24. It would be. Whoa. I'm thinking. Okay, no. We have 1 orange, but we would have potentially 12 of the red ones. Yes, we'd have 12 of the red ones. We'd have 1 orange, 12 of the red ones, and then the rest of them would be the green ones, okay? Because we changed the first dimension. Because essentially, it would look something like this. The way that I drew it, because I changed the first dimension from 2 to 12, then we have 12 of those, and that means there's 12 little lines coming out, and each of those is still containing 1 size 3 array. Okay, so there's going to be basically 12 of those little red ones. Okay, like that. And then each of those contains 3 green. Okay, so that's how we get the total there. Just FYI. But anyways, let's go ahead and deallocate the array. Okay, I got a new chair, but this one's like really hot. I put this fabric on top, but it's not helping. Okay, so let me just rerun Valgrind. Yep. Okay. So now the last thing we're going to do is we are going to deallocate it. Okay. So to deallocate it, we could make another function that takes care of it. However, I'm going to go ahead and switch this to a class first so that I can show you that the best place to deallocate dynamically allocated memory is actually in the destructor. Okay. So you already seen how to use parameters with functions here, or how to use pointers with functions, both as a parameter and a return type. So now let's go ahead and refactor this code and make a class called 3D array. Okay. So, and then, because just if we really wanted to keep it this way, you just make another function very similar to this function here with the same parameters, and then you call delete on that. But we're going to do it in the destructor. Okay. So we're going to make a class called array 3D. Okay. And this class is basically a class that's going to contain everything. We're basically making kind of like a vector class essentially, right? Because like it's an array, but behind the scenes it's like allocating it and everything. So yeah, not as cool, but you know, like ghetto array, ghetto vector. Okay. So in the class, what we need to have is a couple of member variables. Okay. The member variables that we're going to have are going to be the array itself. So as a pointer. So we still have our 3-bit pointer here. And we can call that one the same, just so that the code is easier to copy paste. So array 3D, because we called that before. And we're going to have our 3 dimensions, which are I, J, and K. Okay. Now you could make in a class code like, in fact, we could do that to make it cooler, but I don't know. We could make a class just called like multi-dimensional array. And then the only real change you got to make is No, because then you'd have to make a template because of this pointer here. Nah, we'll just stick with this. We'll stick with this. Okay? Maybe we'll do that some other time. All right, so we got the 3 dimensions and the pointer. Okay? So now we are going to combine the create function and the no, because the initialize one is actually just filling it up with stuff. So what we're going to do is your classes by default have a constructor, right? It's called the default constructor. And that constructor is R3D in this case, okay? That will be the default constructor. Your classes also have a default destructor, which we talked about, but we didn't really give it a purpose, right? Now we're coming back to this and see the real purpose of it, okay? But for now, let's start with the constructor. The constructor runs when the object is first created, right? That's the perfect place to allocate your memory for dynamically allocated memory, so variable. So like if you ever have a variable that you're allocating with new and delete, you want to put all that allocation stuff in the constructor of the class. It's just the best place to do it. And so what we're going to do is we are going to take the code that we had here for make 3D array, and we are going to just throw it in here. Like that. Okay? We can get rid of this int part because that is going to take care of accessing this. And we can go ahead and just have it ready to go. Now, we do want to initialize these with the parameters that are passed in. So those are going to be passed in here. So we can call that like dimension I, dimension J, and dimension K. But these are just parameters, like local variables. If we want to access the ones that are actually down there, we can go ahead and use this. Now this looks weird because we are using the same letter. For me, for one of these, we'll use a different letter. We'll just call it third dimension. That one would be like this, third dimension. Okay? So that's really what it looks like. But in this case, I like to use the same name because it sort of makes it less prone to mistakes, okay? But if you don't like that, if this like bothers you, it just disturbs you, then you can just put a different variable name and do this way, okay? Now, you don't have to do it this way, remember. You could also do it in the body of the constructor, right? You can just do something here that says like third, you know, K equals third dimension like that. That's another way of initializing things, but I like the way above better. By the way, if you do that, if you have the same function name as that, then you have to do something like this, I gets I, if you're doing it this way. And we'll talk more about what the this pointer is maybe next class, okay? But anyways, we have created a constructor, which is essentially what was in the make 3D array function. Okay, everything else remains pretty much the same. Oh, there is one issue that we have right now with this, and that is this. Because we're messing up the dimensions because of that. Yeah. Now that's coming back to bite us. Okay, so we will have to change that because we don't want to mess up the dimensions. So we'll switch it to a for loop. We'll call this Z. In Z is equal to 0, Z is less than I, Z plus plus, and then Z right there. Do you Z that? Okay, yeah, there we go. That fixes most of that issue there. Like that, okay? So, yeah, there we go. So now this will take care of allocating the array. Then we can go ahead and still have our functions that we had before for like printing. So let's go ahead and put the print function inside. For the print function, I am just going to put the prototype and put the function outside the class so that it doesn't get cluttered. So we're just going to call it print. And you don't actually need any parameters in this one. That's good enough. Just make sure you put the return type, which in this case is just void. And then that's it. So now this function, we can convert it into the class name, into the class function by getting rid of the parameters because we don't need them because they're class variables, right? That's the beauty of object-oriented programming. You don't need to pass a billion different parameters. And then make sure you put that this belongs to that scope or to that namespace. So in this case, it's called array or R3D. Scope resolution operator, and then the function name, and now bam, this is now a class function instead of like a solo function, okay? So yeah, and then let's just get rid of. Let's get rid of make. I mean, we could leave this function here for fun. I'll leave it in there because I want to share the code with you guys later. So I'll leave it in there, but you don't really need the function anymore. I'll leave the function prototypes. In fact, because I want to leave that function so that you guys see it, let me copy and paste this. So I can leave also the old print function and make the new one like that. Okay, so I'll put all the old functions down here. Okay, that way you have both, because otherwise you will have lost the other ones, and I want you to have both if you download the code later. So because I do that, so that the code doesn't break as I moved it, let me go ahead and put a function prototype for this one, like that. Okay, so before I break this further, let me make sure that this still compiles as it is now. Yeah. Okay, so R3D does not have any field named third dimension. Oh, did I put those backwards? I did. Third dimension should go outside. Or sorry, inside. Like that. There's undefined variables in print array now. We'll find out in a second. Multiple initializations given at this. Is line 5. I, J, K, I, J. Oh, IJ, sorry. This would be JJ. See, this is why I like this method, because this helps you to fix those errors like that. So that takes care of that typo. And then finally, R was not declared in the scope. That's because it should be R3D. And we don't need the return function anymore here. And I think we should be good to go now. We got more stuff. Let's see. Invalid conversion from int to the int. Huh. Why is it trying to convert it? Oh, because I have still the asterisk here. I don't need the asterisk anymore. Yep. All right. R was not declared in this scope. We got to make all these R3Ds. That's what happens when you copy and paste code instead of rewriting it. One more thing. No member function declared in the scope. That's because we got to change this to just call print instead of print array. Now we should be good. Oh, we got other things in this function now. Okay, so you're right. So now they're not declared in the scope, but they are declared in the class scope. So they should still be okay. So why is it complaining? It shouldn't complain because they're member functions. Oh, probably because I'm screwing it up this way. Yeah. The XYZ. Oh, I see now what you were saying with the XYZ thing. You're right. Damn it. So now I gotta change this all over. So let's pick out the letters. Let's pick A, B, and C for this. A, B, and C. And then A, B, and C. And then A, B, and C. A, B, C. And then finally we can make these I, J, and K as we had them before. So that's why you always want to make a variable and it's more meaningful. Okay, there we go. So I really should have named them like dim1, dim2, and dim3. Like that would have been so much easier. Okay, so all right, it is working now. So we still have the old method here, which I will leave in main, but I will also have the new method, the new format, like up here now. Okay, so the one with the class that we're making. So, okay, so let's keep going with the class then. So we got the print function, we have the allocation. We just need to do the initializing. So for that one, we could do it in the constructor. But what I'm going to do in the constructor is I'm going to call a function that initializes it. How about that? Just because I just don't feel like that really should be in the constructor. If anything, the constructor should initialize things to 0 at that point. I feel like that would be a much nicer way of doing it. So in fact, we'll do that. We'll set everything to 0 in the constructor. I have no idea at this point what variable I should use here. So let's just put T. And then K here, and then T, and then here we're just going to do something like R3DX or ZX, that's horrifying, T gets 0. Okay, so that's just to initialize the entire array to 0. Okay, and then we're going to have another function here that is going to be this basically the init array function. We're going to put it in the class. So that one, we'll copy and paste this part first. Then we don't need any parameters for the function actually. And then the function is basically the same function that we had before. So this function here, init array, minus the, where am I going to put the function? I'll put it here, I guess. I'm going to put everything beneath main so you can see everything better. Array 3D, init array. Get rid of all those parameters like that. And that's it. That's pretty much our, oh, one more colon there. Pretty much our function, okay? So anyways, because you've seen this, let me go ahead and move this beneath main. Okay? That way it is much nicer. And now this function is basically the same function as before, and I'm going to go ahead and move it, okay? Hold on. All right. Okay, so we should be good to go now. X was not declared in the scope. Oh, is it the same issue again? We have the same issue again. Damn it. We'll just copy and paste the other function that we already made. The where is the print function? Here's the print function. So, well, no, not that one. The normal print. This one here. We'll copy and paste this right here into, where is that one? Here. Okay, and then we'll do this, and then just make them A, B, and C. Okay? So now we got ourselves our initialize function there. And we still got to do the delete, but we'll do that at the end. Okay? So let's see what we need to fix here. Line 61. This one's. Okay. There we go. So now we're ready. Now we're ready to actually use the class. So for now, I'm going to go ahead and comment out the old method. I'll leave it in the code so you can play around with it if you want. But now I'm going to use the new method. Okay? So the new method is the class. So that one is called R3D. And I'm just making an array. I'll call it an array. And so that array object is going to basically have already a array initialized automatically at that point in time. So now if I want to see it, I can say array.print. It's called array3D. R3D. So why is it not auto-completing? I don't know why it's not auto-completing. It's probably a typo somewhere. But I'm going to call print. Okay? Maybe this it's not a reserved keyboard as far as I know. No matching function for array. Oh, I got to make it public. I got to make it public. There we go. And then, oh, I see. I got to pass in my parameters. 2, 3, and 4. Right? There we go. That was why it was probably not auto-completing. Okay, cool. So now, if I run it again, I can see that I have all zeros. Okay? That's because when I create the array initially, I dynamically allocate it, and then I set it to all zeros right here. But now let's go ahead and call the initialize function. And then let's call print again so we can see if it initialized correctly. Okay? And there you go. If we run it again, we get different numbers. Well, if we gotta wait a second because of SRAM, there we go. Ooh, that one looks nice because it's nice with space because it's all double-digit numbers. Okay? Great. So now we are going to, last thing we'll do is we're gonna de-allocate. Okay, so we are going to use the destructor for that. So to de-allocate again is you work backwards from the allocation. So you basically will have 3 loops, and you're going to work your way from the green to the red, and finally to the orange. Oh, could you even see the output? I didn't notice that. I don't know if you saw it. Let me see. Yeah, you can see it. Yeah. Okay, cool. All right. So for that, I am going to save time by copying and pasting my loops from print. Okay. So this is looping from each one. And the reason why is because I want to basically de-allocate the green ones, which means I'm going to call delete on each of the stars in the red arrays. So I'm going to say delete this one, 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 delete this one. So it takes care of that, and that. Okay? So I will do that in here by saying delete R3D and then A and B. Okay? And because it's not a single pointer but an array, I gotta put that in front of it. That is gonna take care of deleting the green squares. After I'm done with those, I wanna go ahead and delete the outside squares. The red ones. To delete the red ones, that's going to be in the outer loop here. So how many times do I have to call delete on the red ones? Well, I have to call it the number of times that I have squares here. So that's 2 of them. Okay? So that's going in the outer part of the loop. So this one. So delete array and then R3D, but in this case just 1 dimension, which is A. Again, that's just 2 spots basically I'm deleting. Finally, I gotta delete the orange square or yellow square. That's outside of all loops because it's just a single delete all the time, the last dimension always. So that's just delete R3D, like that. That will take care of deleting everything. And finally, for dangling pointers and whatnot, just to be extra safe, I suppose, even though technically speaking, the constructor runs when the object goes out of scope, so you shouldn't have dangling pointers in the first place. But I feel better if I do it this way. I'll just go ahead and say R3D gets null. Okay, that's just like basically I am cutting that link off so I don't access things by accident. And there we go. If we now go ahead and rerun this and fix the codes, let's see, put a semicolon there. All right, that was fast. We run it, everything is running still fine, but now let's go ahead and run Valgrind and see if we really fixed the memory leaks. And there we go. No memory leaks. Well, here, hold on a second. I'll just get rid of that now. We don't need that anymore. But yeah, no memory leaks. If you wanted to do the same thing with the version that is not an object, then you would just basically put this in a function right here. And then you'd be good to go. In fact, I could probably do it really, really fast. I kind of want to move on, but I'll do it. I'll just put the function here. So we'll call this function void delete array. And it needs to have the parameters, which are int 123, ar3d, int I, int j, int k. And that's going to do everything good with the exception of this setting to null will not work here. It's not going to, it's not setting the pointer. It's just setting a copy of the pointer, so it's useless to do there. There's ways around that, but I have to rewrite the code. I'm not doing that now. So yeah, okay, that's pretty much it. That should work. Let's just test it real fast. So let's uncomment this and then add the function delete array. There, R, delete R. No, let's be consistent with naming conventions. Let's do that. Delete array. And then basically the same parameters as before. And then we'll see if it works. So we have 2 arrays in here, technically, and they are both okay. So, see, done. That was actually painless. Let me go ahead and move this function beneath again, because there's a couple of more things I want to do. So let's just put that down here. And let's put the function prototype up here. I'll leave that like that. Run it one more time just to show you that everything is still okay. All right, everything is still okay. So now I'm gonna start commenting things out because the code is really big. Okay, so I'm gonna comment everything out. Two things I want to show you real fast. Suppose we want to make it the array through the object. We want to make it a pointer. Okay, let's just make it a pointer just to show you that it still works. Array 3D pointer R. If we do that, we'll be okay. Yeah, we'll be okay. But then we have to do the new, and then we do R3D 2, 3, 4 like that. And then if we want to call print, we would have to do something like R print like that. And then to avoid memory leaks, we have to manually call delete R. And when we do that, that delete R, that will call the constructor. It should call the constructor. The destructor, sorry, of the class. And avoid memory leaks, as you can see. Okay? So it's not initialized, but we could initialize it by putting R emit array, you know, and then R print like that. And so here's the thing I want to emphasize about this whole mess, okay? Because like, look, that's really cool. Because remember, you want to avoid memory leaks, right? Not just because you lose points, but in general in life, you want to avoid memory leaks. But here's the power of this. By using the destructor and the constructor for initializing your memory and the destructor for deallocating your memory, you really make your life much easier. Look how easy this is. I went ahead and just created an object. I used the object, and then I called delete on the object. And that's it. I don't have to worry about anything else because I have prepared that ahead of time by putting in the constructor over here, the allocation stuff, all the dynamic stuff, and then in the destructor, all the de-allocation stuff. So I don't have to worry about any of that. Otherwise, if I didn't, I'd have to call delete array manually here, right? In the version of the codes where I'm not using a class, I have to manually call some function that initializes or code that directly in main, and then the same thing for de-allocating, right? Here, it is handled automatically, and you know, be behind the back. I'm not worried about it. Okay, so cool. That took longer than expected, but that's fine because it's a nice big example with classes. Here's a couple of things. If we go back and look at the list of topics that I want to talk about, the next thing I want to do is shallow versus deep copy. So we already did the constructor and destructors, so that's pretty nice. But we still got to do shallow versus deep and then the C stuff. The C stuff we might not get to, but shallow versus deep. So here's a couple of tiny things that happen when you're dealing with classes and dynamic allocation. Suppose that I made an object, as I did here with array 3D, like this one. So maybe comment this part out only. Suppose that I went ahead and say array, let's make 2 of them. So let's make another array. We'll call this one array 2. Suppose that I try to copy array 2 or array 1 into array 2 like that. Okay? If I run this, it compiles and it runs even, but it's got memory leaks and errors, which is even worse. Here's the thing. When you copy an array in general, first of all, if you try to copy an array that you allocate statically, you get an error. It says you can't even copy it. However, when you're copying an object, it actually does copy it. But here's the catch. When you're copying the array, it copies the members of it. So it's going to copy I, J, and K. So I, J, and K will indeed be correct. Like if I was to go ahead and put in here, like cout array2.k, you know, we would see that this does indeed have what we expect it to be, which is whatever the dimension is. So, come on, all the errors. The 4, okay? So it has the 4. So k is equal to 4. Is that the dimension? Yeah, it is, okay. So that is copying things as it should. However, here's the issue. If I try to change something in array 2, so let's say array 2, the first spot, 0, 0, 0, I'm going to make that 99. Okay? And now I'm going to call print on both arrays. Array 2 print and array 1 print. Let's get rid of Balgram for a minute here. Oh, I don't have direct access to this. Sorry, I gotta do array2 dot array3d dot. There we go. That's actually changing the contents of it. And then it's not called array 1, it's just called array. All right. So run it. Segmentation fault. Why you get segmentation fault? Let's try doing it this way instead. See if we still get segmentation fault there. Why am I getting segmentation fault there? GDB a.out run. Oh, did I free that at some point before that? Oh, I know why I'm getting segmentation fault. Sorry, I just probably yelled into the microphone. Because of what I want to show you is why I'm getting segmentation fault, actually. And so for a minute here, let me go ahead and comment out the destructor, because that's causing the segmentation fault. For a very good reason that I want to point out. But before I want to point out something else. So I'm coming out the destructor just to show you something here, okay? Okay, cool. So look, I changed 99 on one of the arrays, right? Doesn't matter which one I change it. In this case, I changed it on the first one. But guess what? It did not just change it on the first one. It changed it in both arrays 1 and array 2, because this is array 1 or just array, and this is array 2. So even though array 2 is a copy of array 1, it's not a real copy of it. And this is also the side effect that I'm getting here with the segmentation fault. Here's what happens. When you're copying an object, it copies all of the member variables. It copies I, J, and K. No problem. It's making a copy into a brand new one. That's cool. Here's the problem. When it's copying the pointer, which is holding the dynamically allocated array, it's literally copying the pointer. What does that mean? It's copying the address of the pointer. So the new array, array 2, is holding an address in that array 3D pointer. And that address is still the address of the old array. So what you're doing when you're making that copy with the assignment operator here is you're just copying the address. You're not making a brand new array. So essentially you got two objects that are both pointing to the same 3D array that we've made. That's a problem. This is what is known in C++ as making a shallow copy, because really you're just copying the reference. You're not making an actual deep copy, which is what we call when you actually copy everything together. Okay? This is a problem. It's a big problem right here, because that's actually going to screw things up. Now, why does that cause a segmentation fault? Here's the thing. When you make the copy of this, when you go out of scope, so when you finish and you call and delete on the object, or the object goes out of scope, it automatically calls the destructor, right? So the destructor takes care of de-allocating, calling delete on that array. But here's the thing. You have two classes, you have two objects that are both pointing to the same array. One of them is going to eventually get called to the destructor before the other one. The first one is going to delete it and it's going to be fine. The second one is going to try to delete the same array you already deleted, because they're both pointing to the same one. And that's a double delete, and that's what's causing the segmentation fault. So if we copy the two classes, but if they do not have pointers, will it work perfectly fine? Yes, it will work perfectly fine. The problem are the pointers, which are caused by the dynamic memory allocation, because what it's doing is it's literally copying the pointer, which is just the address. If the pointer says address 50, then they're both pointing to address 50. And so what is the solution to this? The solution to this is to make a deep copy, which means either make a brand new array and manually put a for loop where you copy the member, so you call it a member-wise copy, which you can do. Or when we talk about operator overloading, I will show you how to overload the assignment operator, so you can put that for loop inside of the assignment operator, so you don't, so like this will still work. And that's actually how vectors do it, because vectors, you can do this. You can make a vector equal to another vector, and it's and you don't see what's happening behind the scenes. But behind the scenes, they gotta create a brand new array, copy everything in a loop, in the for loop that's copying every single member one at a time, and then you're good. There's no magical copy everything at once thing, because again, all that you're copying normally is just the contents of the pointer, which is the address, right? So hopefully that makes sense. And it also makes sense as to why you get the seg fault, because they're both pointing to the same array, and they're both things are trying to delete it. And one of them will delete it fine, but then the second one's like, yo, you're deleting me, but I'm already deleted. Segmentation fault. Program crashed. Okay? So that's shallow versus deep copy. I can show you next time a quick example of how to avoid that. But it's basically you're just going to you have to make a new object, you have to initialize the new object, and then you got to put a for loop that just copies each member. But again, we'll do that more in detail when we talk about our operator overloading as well. Okay? There's also other problems like the copy constructor. I'll show you that at some point too. Copy constructor is the fact that like if you have an object A and you want to initialize that object with some other object's content, you know, it could be like something like A2. And so if you have an object A2 already and you're making an object A, you can do this, right? Assuming the class is called A. Actually, it would make more sense that this is called A1 to A2 like that. So if this is some line of code somewhere, you have a class A and you have already initialized an object called A1 and you're making an object A2. You can put the syntax. Oh, you can't see that. Shoot. There we go. Okay. So you have a class A and you have an object called A1 and you're going to make an object A2, but you want to make the object A2 be a copy of A1. You can also use the syntax too to make that copy. And so this will work just fine because it will take A1's contents and fill it in A2. But you'll run into the same problem if you have dynamic allocation with pointers, because again, it will just copy the address. So it's the same problem, shallow versus deep. So we'll go over this more in detail next time, but I want to make you aware of that because that's it's a little bit of a headache actually, but easy solution. You just copy things by hand and you're good to go. Or if you want to make it nicer, overload the operators, which we'll learn in like 2 weeks, or it'll be after the test. So, yep, that's it. We did a lot of code today, but we actually almost covered everything I wanted. Like we just kind of did it all in one big example because we did the constructors and destructors. We did kind of shallow versus deep now. We did 3D stuff. And the only thing that we really have to that I want to do, but frankly it's not part of the course, so even if you don't do it, that's okay. But I kind of want to do it, is C memory allocation, which should take me like 10 minutes to show you really, maybe even less. So we'll do that probably at the start of next class. And then from there we'll talk about up and down casting and virtuals. And then you'll have your test in the week after that. So thank you for watching. I hope that this big example is helpful. Like I said, I will make the code available within a few minutes. Just let me push it online and refresh and you'll be good to go. I'll just make sure it still compiles. So, yep, thank you for coming. Enjoy your weekend since I won't see you until Monday. Get some rest, get the assignment done. And yeah, that's it. So see you guys. Thanks for coming. Take care. Bye and stay safe.